In 2018, there were only 2 questions based on algebra. There are 2 quadratic equations have a common root. Let the 3 unique roots of the 2 equations be a, b, and c. All of them are positive integers. If a plus b plus c is 41 and the product of one of the equation is 31, 35. So let's say the 2 roots of this equation are a and b, and the 2 roots is a and z. I'm taking the common root as a. You can take it any common root. So this is the first equation, that is the second equation. And you can take it any equation here. Whether you can take it a into b or you can take it a into c. A plus b plus c is given as 41. And the product of one of the equation is 35. So let's say I'm taking a into b. A into b is given 35 and they're positive integers. So product 35 we can get it 2 ways. Whether it can be 1 into 35 or it can be 5 into 7 or vice versa. 35 into 1 or 7 into 5. Know the possibilities? So if I take 1 and 35, what is the value of c? The value of c comes out to be 36, 5. If I take 7 and 5, 12, what is the value of c? The 12, 29. And if I take the reverse, 7 and 5 again will not change, 1 and 5 will not change. So the 4 possible roots of this equation can be, the common root can be 1 and 5 and 1 and 35. The common root can be 5 and 7 and 5 and 39. So now let's check the option. The common root is 29. It's definitely correct. The common root is 39, 29, not necessarily. The common root may be 1, the common root may be 5. The smallest among the root is 1. The smallest among the roots is 1. If I take the common root as 1, yes, that is possible. But answer is giving something different. Answer is 5. The smallest among the roots is 1. Okay, not necessarily. Why? Because the roots can be 5, 7 and 29 as well. Right? Not necessarily the roots are 1 and 35. No? The roots may be 5 and 7. If the roots of this equation are 5 and 7, the roots of the other equation can be 5 and 29. So the smallest root among the option is 1. That is not definitely true. But look at this option. One of the root is 5. Now if I'm taking the first option 1 and 35, if I'm taking 1 and 35, the third root is coming out to be 5. Right? So the root will become 1 and 35 and 1 and 5. And if I'm taking second case, which is 5 and 7, then the roots are coming out to be 5 and 7 and 5 and 29. So one thing is very sure, whether I take this case or any of the case, one of the root definitely has to be 5. So whether I take this case, one of the root is coming out to be 5. If I take this case, one of the root is coming out to be 5. So that statement is definitely true. Product of the root is equation is 5, not necessarily. Here it is the case. The product of the other root can be 145 as well. So that is not definitely true. All the above possible, none are definitely not correct. That is also not the case because third has to be definitely correct. Okay. Come to the last question of 2018. So your algebra part will be over now. In the next session, I will take geometry or either arithmetic or modern maths. Now here again you have to make cases. Now x minus 1 mod into y plus 3 mod. The product is in the range of 5 and 2. The product is in the range of 5 and 2. If both x and y are negative integers, find the number of possible combination of x and y. Now as you can see, this term x minus y, if I take x as negative integer, let's say x is minus 1. If I take x as minus 1, that x minus 1 mod will become 2. if it is 2, the product 2 into y plus 3 mod should lie in the range of 5 to 2. So what can be the value of y plus 3? The y plus 3 can be 1. The y plus 3 can be 2. Y plus 3 cannot be 3. Otherwise the product will be more than 5. So if I take y plus 3 as 1, if y plus 3 is 1, y plus 3 can be either 1 or y plus 3 can be minus 1. So from here I'll get y is minus 2, and from here I'll get y as minus 4. So if I take x as minus 1, right now I'm getting two values of y. Similarly, if I take y plus 3 as 2, y plus 3 can be 2 or y plus 3 can be minus 2. So from here I'll get y is minus 3, and from here minus 1, and from here I'll get y is minus 5. Again negative, valid values. So if I take x as minus 1, I'm getting 4 values of y. 4 values of y. Now the other case, if I take x equal to minus 2. If I take x equal to minus 2, x minus 1 mod will be plus 1. Sorry, it will be minus 2 and it will be 3. So if it is 3 into y plus 3 should lie in the range of 5 to 2. Obviously it cannot be 2. So y plus 3 this time can only be 1. If it can be 1, I cannot take 2. So I'll get two more values. Y plus 3 can be 1, y plus 3 can be minus 1. So y will be either minus 2 or y will be minus 4. So with x minus 2, I'm getting two values. And let's check the last one. X is minus 3. If x is minus 3, x minus 1 will be 4. So 4 into y plus 3, obviously the same thing, y plus 3 can be 1 only. So two more values. We need not to solve it now. And last, if x is minus 4, this will become 5. And 5 into y plus 3 can be equal to 5. So y plus 3 has to be 1 again. So y plus 3 is 1, again I'm getting two values. And I cannot take it minus 5, because if I take minus 5, this will become 6. That is not possible. So total possible values are coming out to be 10. So 4 values, 2 values, 2 values and 2 values. So total values are coming out to be 10. That is the correct answer. Combination of x and y. The combination of x and y is with minus 1 4 values, with minus 2 2 values. So 10 possible combination of x and y.